Okay, so what I want to do now is cover a topic called piecewise functions, and we're going to be doing linear functions. And basically, what a piecewise function means is we're going to define our function in pieces, because normally when we graph a function, it's just one equation. So in this case, our function f of x is going to be broken up into two separate functions. However, it's really only one function. I don't know if that was confusing or not, but basically, so we're going to graph the absolute value of x minus 1 and x minus 1 all on one coordinate plane, but it has restrictions to what interval are we going to graph it. Okay, so it's probably a lot of nerdiness right there. Let me just show you what I mean. You're going to be like, oh, all right, I see what's going on here. All right, so what we want to do right now is we want to graph this guy right here. Let's graph the absolute value of x minus 1. Okay. Now, if we graph the absolute value of x minus 1, then that means that you graph the absolute value of x, but then you shift it down 1. So normally the vertex would be here at 0, 0, but since that minus 1, it brings it down 1. Bloop. So really, it looks like this, right? You just put the little dots there, and it would look just like that, right? So if you were to graph this, it would look something like that, though. Now, here's what the restrictions are. It says graph the absolute value of x minus 1 only when x is greater than negative 1. That's it. So watch this. I go to the x-axis. See how the x-axis right here is negative 1? Only when x is greater. So that means 0, 1, 2, 3, 4, 5. So they want us to graph everything over here, but stop at negative 1. Okay, so what I need to do then, check this out here. Do you guys see right here how this does not have a line underneath it? Like it's not greater than or equal to. It just means x must be greater than negative 1, meaning x cannot be negative 1. It says x must be greater than negative 1. So that means I can't put a dot at negative 1, because if I put a solid dot there, then that means that x is greater than negative 1 or equal to. So what we do in this case is this. Since there's no line underneath here, we're going to put an open circle. Just like that, we're going to put an open circle where there would have been a closed dot. And then we can go ahead and make our graph now. So we know this is going to look like this. That looks like that. And that looks like that right there. Okay, so it's like a half of a absolute value, and then it kind of goes up and it stops right there. And the reason why I put an open circle is because this says x must be greater than negative 1, not equal to. If it was equal to, then it would have a line right here, and we would make that a solid dot. Now, we need to graph the line now, x minus 1, where x is less than or equal to negative 1. Okay, so let's graph this. Okay, so if you remember, like when we graph lines x minus 1, this negative 1 right here is the y-intercept, and the number in front of the x is called our slope. So the y-intercept, and I'll do this like in black here, the y-intercept is negative 1, so I'm going to put a dot right here at negative 1. Okay, this is, and since the slope is 1, and there's a 1 on the bottom, right? There's a ghostly 1 on top and a ghostly 1 on the bottom. So that means from 1, I go up 1 over 1, up 1 over 1, up 1 over 1. However, we're supposed to graph only when x is less than or equal to negative 1. Meaning, really, I shouldn't put a dot here because this is at 0. Let's go to negative 1, right? So it goes down 1 over 1, dot. Down 1 over 1, down 1 over 1. Okay, like how am I getting this right here? Because right here, the slope is 1 right here, right? So I go up 1 over 1, but since I can't go to the right, I have to go back down the other way. So I'm going to go down 1 over 1, down 1 over 1. So see how that's going to be a closed dot right there. This would be a solid dot at the point negative 1, negative 2, because look right here. When x is less than or equal to negative 1. So I have to put a solid dot right there. This would be an open dot. right there. So this is what this piecewise function looks like. You're like, oh, dude, that's pretty weird. That's how we graph those guys. We got to graph two different functions, and we need to have restrictions on when we graph them. All right, let's do another one here. We're going to graph the line 1/2 x plus 2 when x is greater than or equal to -2. So let's do that first. Okay. So if I'm going to graph this 2 means that's my y-intercept, 1, 2. And that means I go up 1 over 2. Up 1 over 2. So up 1 over 2. Up 1 over 2. Up 1 over 2. And we can go the other way. Down 1 over 2. Down 1 over 2. Down 1 over 2. So that's really cool that's really neat about the slope. It gives us infinite points. However, we don't want this whole thing. I mean, look at the restrictions. Only graph this when x is greater than or equal to -2. So let's go to -2, which is right here. Okay, this is -2. So that needs to be a solid dot, and everything that's greater than -2 when x is greater than. So that means from here, everything to the right. So that means I need to get rid of that right there, and I could connect these guys and get my line. So it looks something like that. Okay, now let's graph -x minus 3 when x is less than -2. So let's just graph the whole thing, and then we'll erase what we don't need. Okay, so this -3 means I start at -3. 1, 2, 3. Okay, and this -x means it's a -1 on top and a 1 on the bottom. There's always a ghostly 1 on top and a ghostly 1 on the bottom. So I'm going to go down 1 over 1. Down 1 over 1. Down 1 over 1. And we'll go the other way. Up 1 over 1. Up 1 over 1. Up 1 over 1. And this thing just keeps going. So we only want to graph this line right here when x is less than -2. When it's less than. So let's go to -2. Here it is. And see how that's a solid circle? But look, it's supposed to be an open circle because there's no line right here. So really, we want to get rid of all this, and at the point -2, we're going to want to put an open circle. That is extremely important. Do not put a close dot right there because it's not equal to -2. It has to be less than it. And we use the open circle to indicate it's not equal to that number. All right? And then it's going to go to the left of that. So I'll do my little arrow thing. It's going to go that way. Okay, so that would be our piecewise function for that little dude.